Hello, this is Mr. Brandenberger, and we're going to talk today a little bit about density. Okay, you started learning about density in the 6th grade, and then this year in the 8th grade, you've done a little bit more with density. All right, so density is the mass per unit volume of a substance. That's the definition of it. So make sure you copy that onto your paper, your notes. Density is the mass per unit volume of a substance, and we're going to see what that means in just a little bit. All right, density is a property useful in identifying substances. All substances have different densities, and you can use it to identify them. All right. To find an object's density, you find the object's mass. Okay, and then you have to find the object's volume either by calculating it with length times width times height. But that has to be if it is a regular figure like a cube or a rectangular prism. If it's not a rectangular prism or a cube, you can find an object's volume by water displacement. What the heck is water displacement? Okay, well, you might remember we did this in 6th grade. You take a graduated cylinder and you fill it with a certain amount of water, like this one here is filled up to 200, and then you drop in an object, like they dropped in this rock. And then when they dropped in the rock, you see the volume went up because the amount that it went up is the volume of that rock. So you subtract them, you take the ending volume minus the beginning volume, and that gives you the volume of the object. All right. The formula for density. Okay, remember in 6th grade we learned I heart density. Now what the heck does that mean? All right, density, the little heart here means, see the top of the heart looks like an M, and the bottom of the heart looks like a V. So the top of the heart with the M, that can stand for mass, and the bottom of the heart can stand for V for volume, and then the line through it is the little fraction bar. So density is mass divided by volume. That's how you remember it. I heart density, mass divided by volume. All right. So this is a formula triangle that you can use to solve density problems. You can substitute in your numbers for density, mass, and volume, and then use the formula triangle just like you did for speed, speed, distance, and time. This time D is density, M is mass, and V is volume. So if you are looking for a density and you have the mass and the volume, then you see right here would be mass divided by volume. All right. Density determines buoyancy, and buoyancy means whether something floats. All right, an object will float in a liquid if it is less dense than the liquid. All right, so if the density of the object is less than the density of the liquid, it'll float. An object will sink in a liquid if it is more dense than the liquid. So if the object has a greater density than the liquid, it'll sink. All right, for water, the density of water is 1. So it's real easy to calculate if something will sink or float in water. If its density is greater than 1, it'll sink. If it's less than 1, it will float. All right, so let's look at the practice problems. Let's look at the first one on your page. All right, a student is to find the density of the cube shown below to determine if it's a metal or a metalloid. Okay, whether it's metal or metalloid doesn't matter. You need to find the density of it. And they gave you the side length of this cube is 4 centimeters. Each side is 4 centimeters. And the mass is 21 grams. All right. You need to remember your density formula. I heart density. That means density is mass divided by volume. Okay, so you need to write this formula down on your paper somewhere. Density equals mass divided by volume. All right. So let's look and see what we have over here for our problem. We have the mass is 21 grams. Okay. So we can put in that mass, 21 grams. Okay, now we need to put in the volume. But if we look over here at the problem, there is no volume. All we have is the side length of the cube, which is 4 centimeters. Okay, but that's okay. Cube is a regular figure, and the volume is length times width times height. All right. Since it is a cube, the length and the width and the height are all the same. They're all 4 centimeters. So you can put 4 centimeters in. But first I want you to write down this formula. Volume equals length times width times height. And then once you write that down, right below it, you can put in 4 centimeters for each one of those length, width, and height. And then you're going to have volume equals 4 times 4 times 4. All right? So when you do the math, 4 times 4 is 16, and 16 times 4 is 64. It's also the same thing as 4 cubed, or 4 to the third power, and that's 64 cubic centimeters. All right, so now we know what the volume is, 64 cubic centimeters, and we can put that in our formula. Density equals 21 grams divided by 64 cubic centimeters. All right, that problem is ugly. If you want to solve this the regular way, you've got to do 21 divided by 64. And you can tell right away, since the numerator is less than the denominator, it's going to be a decimal. All right. Well, let's take a look at our answer choices. Okay, if we look at answer choice A and answer choice C, those both end in a 5. And neither one of the numerator or denominator have a 0 or a 5 in them, so those are most likely not going to be correct. So we can cross those out right away. And then we're left with 1.3 grams per cubic centimeter and 0.33 grams per cubic centimeter. All right. Well, like we just said earlier, the numerator is less than the denominator. This is a fraction that is going to be less than 1 because the numerator is less than the denominator. Look at your answer choices. 1 is greater than 1 is 1.3, and 1 is less than 1, 0.33. So guess what? Your answer is 0.33 grams per cubic centimeter. If you want to do the math, go ahead. 21 divided by 64, it's going to give you an ugly decimal that's just about 0.33. That's how you solve that one. Okay, for number 2, it says the density values of 4 irregularly shaped objects are shown in the table below. These are the densities. Which object's density can be calculated from the measurements of 18.8 milliliters and 17.5 grams. All right. You remember, you have to set it up. You have to write the equation density equals mass divided by volume. And then you have to figure out which one of these is mass and which one's volume. Well, volume is measured in milliliters, so that's your volume. And mass is measured in grams, so that's your mass. So you do mass divided by volume. Once you set the problem up, take a look at these densities. One of them's less than 1, the other ones are greater than 1. That should help you. All right. For number 3, a student calculates the density of an unknown metal sample to be 8.25 grams per cubic centimeter. Which set of data from the student's notebook correctly calculates the density of his unknown sample? All right, well, you just have to try. Set up your equation, density equals mass divided by volume. And here's your mass and here's your volume. And you try these until you find the one that comes out to 8.25. All right, number 4. Students calculated the density of 4 objects having the same mass and different volumes. According to the information in the table above, what's the density of object Z? And then once you find it, you have to bubble it in. All right. You don't know what the mass is, but they were all the same mass. So you just have to take a look. Density is mass divided by volume, so some mass divided by 2 equals 2. The same mass divided by 8 equals 0.5. The same mass divided by 4 equals 1. So what is that mass that, when you divide it by these volumes, gets you these numbers? I would start with this Y one right here. Something divided by 4 equals 1. That's pretty easy. And then once you find that mass, then you take that mass divided by 16, the volume of 16, and that gets you whatever the density of this Z is, and that's your answer.